Sets. Here, what happens here very clearly, procedure. What I'm doing here, I'm explaining about the procedure. Please understand, I'm explaining about the procedure. I'm explaining about the procedure. Okay, I'm explaining about the procedure, how it works. How it works. I'm telling you. I'm explaining about the procedure, how it will going to work. Now see, in this, basically what happens, just a moment, right. So what I will do, wait guys, this is actually a little bit complex, you will not understand. 1 minute. So we'll see the Prim's algorithm. Prim's algorithm. Prim's algorithm. Okay. So what is this Prim's algorithm? We're going to see this one. Here also same thing. Please be careful these words. Vertex, vertex by vertex. Vertex by vertex. Okay, na? Vertex by vertex. Now, everybody observe here. What happens here in the Prim's algorithm? It is always connected. I will going to write the graph. Please observe here. I will going to write the graph. The graph is like this. A, okay, na? B, C, okay. Let's see. So that is D. Okay. Here I will take C. Again here I will take it E. Again here I will take it F. Okay, fine. This is fine. Now I will going to connect from here to here. Again I will going to connect from here to here. I will going to connect from here to here. Again I will want to connect from here to here. I will connect from here to here. 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 Again from here to here. Okay, I connected. Let me give some weights. 7. Okay, here 4. Again here 6. Here 2. Again here again 6. Again here again 6. Here again 8. Here again 5. Here again 3. Here again 9. Okay, so these are the things. So these are the weights we have right now. Please understand, these are the weights we have right now. Again, one more keyword I will give you. One more keyword. What is that keyword? Is nothing but adjacent. Please observe here. Adjacent. Adjacent. Adjacent better. Adjacent better. So this is the keyword. Adjacent better we have to look into. Okay. So again, first what we will do, this method will give you vertex by vertex. This is vertex by vertex. Okay, na? And one more line, please take it one more line here. Adjacent, adjacent, best one, we have to take, because end of the day, MST, nothing but minimum spanning tree. Okay, minimum spanning tree possible. Okay, we have to take the best. Okay, adjacent best we have to take it. Then only we can able to, end of the day we can able to create the MST. This is one. Again, sir, we understood everything what you are talking about, vertex by vertex. Hence, before we are doing what is that, edge by edge. Here we are doing vertex by vertex. How we will do? Again, where I have to start here? There you are taking minimum. You are taking minimum over there. Where in Kruskal you are taking minimum edge. But here, how you will going to take? That is the first question. That is the first question. How you will going to take, sir? Here, which edge you will going to, which vertex you will going to start? Will you going to start from F? Will you going to start from V? Or will you going to start from B? Or will you going to start from A? Which vertex you will going to start? Let me tell. So for that one, I will going to tell you. Answer is, please here. Answer is very simple. start from, start from any vertex, any vertex, start from any vertex. Okay, now start from any vertex, no problem. You don't have any problem in this. Okay, you don't have any problem. Okay, now here everyone, you don't have any problem. You can start from any vertex. That is not a big issue here. Now, step one. Everybody observe here, like that only. Step one, step two. I will go to clear. Everybody, please observe. Step one. Step one. Okay, step one. What we will do in the step one? Step one, what we're going to do, basically, we will going to take one edge. Sorry, we will going to take one vertex. So what is that vertex? If you want it, you can able to select A. If you want it, you can able to select D. If you want it, you can able to select C. If you want it, you can able to select B or E or F. Which one you want it, you select, no problem. Okay, na? Which one you want it, you select, no problem with that. Clear everyone? What I will going to do, I will going to select the vertex A first. I will go to select the vertex A. Now from the vertex A, see, from the vertex A, check the degree of this vertex. Okay, there is a 3 paths are available, nothing but 3. That is degree is 3 here. Yes or not? Degree is 3 here. Everybody observe here, degree is 3 here. Again, adjacent, best adjacent, you check it. Nothing but what is the best adjacent? Suppose I wanted to travel from A to D. How much time, how many units you are taking? 6 units you are taking. Suppose think like that. I wanted to travel from A to C. How much units you are taking? 2 units you are taking. Suppose I wanted to travel from A to B. How much units you are taking? 7 units you are taking. Correct? 7 units you are taking. But so to cover C, how much units it is taking? Only 2. Yes or not? Only 2. That is the reason why you take minimum. That is what we call it as best here. That is what we call it as best one. Best adjacent one, you have to choose it. Now you people got it. So take any vertex, in that vertex. Okay, so check the degree. Okay, there is a degree 3. In that you select the best adjacent one. So what is the best adjacent one is? That is A to C. That is A to C. Select that one. Understood everyone? A to C. That is the one. Select that one. A to C. Okay, done. Everybody got it now? Everybody got it? So this is the weight is 2. Clear now? Anybody have? So this is a connected one. This is connected right now. This is connected right now. Got it? Everybody got it? So this is connected right now. This is the step one we have to do. Nothing but A. See here, everybody observe here. A. Okay, for A. And again, next step, what you will going to do? Select the best adjacent for A. Select the best adjacent for C. That is what you have to do. Okay. Select the best adjacent for A. Again, select the best adjacent for C. That is what you have to do. Okay. Now see here. What I will going to do? Step one is okay. Everyone okay with the step one? Again, go to the step two. Okay, so go to the step 2 here. Step 2. Step 2. Finish. Now, okay, we got this one. A is fine. Again, C is also fine. A to C is connected. Weight is 2. Now, from A, see here, everyone observe here. A, what is the degree from A? A to, so there is a degree 3 from A. Okay, which one we have covered already? C covered. Yes or not? This one is covered already. Left is what? 7 and as well as D is left here. 7 and 6 paths are left here. Yes or not? 7 and 6 paths are left here. Now, so go to C. Again, here also C is there. Check how many paths are available for C. Again, you can able to see 6 is there. Again, 6 is there. B to D is there. B to B is there. Again, B to C to A is already over. Yes or not? C to A already over. So that is the reason why for best one for A actually 6. Yes or not? Best one for actually 6 is there. But for C also I have to check it. Yes or not? For C also I have to check it. Again, if I check for C, you please observe here. If you check for C, I am getting the best one. See here, I am getting the best one from C to F. That is a 5. Minimum is 5. Compared to 6, this is lesser. 5 is lesser. That is the reason why I will going to connect to F. Clear everyone? See the minimum. Please see the minimum. Actually, A to D, that is also okay. A to D, that is also okay. So when it comes to C adjacent, okay, it will going to reach the F within 5 units. So that is the best one. That is the reason why I'm taking that one. So that is also over. Yes or not? That is also over. That is step 2. This is the step 2. Again step 3. Step 3. Okay. In this step 3, that is fine. Everything is fine. So A, from A to C, that is over. That is 2. Fine. That is also over. Again C to F, that is also fine. That is 5. Again F2. Now see here, F2. From F, which one you will want to select? That is what we have to do. See, from F2, see, that is already over. This one is over already. F2E, it will take 9 units, but F2D, it takes only 3 units. Nothing but which is the best adjacent for this? Which is the best adjacent for F? That is 3. Basically, when you go to the A, best adjacent is we got 2. Again, when you go to the C, best adjacent we got. Basically, you can able to see everything. It will cover C, A, it will cover B, it will cover E, it will cover F, it will going to cover D, it will going to cover. But on all these paths, in all these paths, which is the best one? 50 is the best one for F. 9 is also adjacent. Again, 3 is also adjacent. So 9 is adjacent for E. Again, D is adjacent. 3 is adjacent for D. Which is the best one? You will going to take it. Basically, I will going to take 3. So that's why F to D. So that value is 3. Okay, done. Everybody done? Okay. Any problem? All right. Again, step 4. Okay, here I will write step 4. Here I will write step 4. Step 4. Okay, now step 4. What we'll want to do? Again, one more important thing here. So everything is fine here. I will take this one. What is that? A. Okay. So A to C. That is also fine. Again, C to F. That is also fine. Again, F to D. That is also fine. Okay. So that is what is the value? That is 2. Again, C to F. That is fine. Okay. Again, this is 3. So these things we got. Now check everywhere. Everybody check for this one. A adjacent also you have to check it. Again, C adjacent also you have to check it. F adjacent also you have to check it. Again, D adjacent also we have to check it. See, now when you go to this one, please observe, when you go to this one, what happens here exactly? Whether the cycle is forming or not, we have to check it. Okay, whether the cycle is forming or not, we have to check it. That is what exactly you have to do. It's a connected graph. Now you can able to see it is not creating any forest. Please understand, it is not creating any forest. This is creating a connected graph here. Edge by edge, it is connecting or not? Please see here. Sorry, vertex by vertex, it is connecting or not? So in that cruscal, what happens here? Here forest is creating, because sometimes it is connected, sometimes it is not connected. But here it is not like that. Please understand. But here it is not like that. So what we are doing here? So we are connecting each and every vertex in every step. That is what you have to understand. In fourth step, what happens here? Check this one. Okay, everybody observe here. Check this one. So A to D also we okay. Okay. So that is 3, 5 done. Now check here. From C to D. If I go from C to D, everybody observe. If I go from C to D, what happens? C to D, what happens? Cycle creates. Please ignore. Cycle creates means just ignore. No need to worry. Just ignore. Okay, that is not possible. This is not possible. Again, check. Check other. A to D. A to D. If I go to A to D, see, that is also cycle possible. That's why leave that one. So that is also over. Again, check with. Okay. What is that? F is there. F to D. If I do F to D, again cycle creates. Leave that. Okay, nothing but we checked all the combinations. It's not working. But here C to B you check it. C to B you check it. Is it okay? So that's why. No cycle is created. That's the reason why B. No cycle is created. That is the reason why it's B. Fine. Fine, okay. And one more important thing is in this, Prim's algorithm, if it is a connected graph, see here, if it is a connected graph, cycle checking is easy. Cycle checking is easy. Cycle checking. Cycle checking is easy if it is a connected. Okay, yes or not? If it is a connected, it's very easy. Cycle checking is easy or not? Yes or not, guys? See, you can able to see from A to D. Suppose take this one. For example, you take this one. If you are not able to understand, example you take it. First vertex I have taken nothing but I visited this one. Yes or not? I visited this one. Already D also is there. This is also visited. This is also visited. Nothing but what? Cycle formation is possible. Okay. See here from A to D. You can able to see from A to D. So cycle formation is possible. Example from F to D. Okay, this is also visited. This is also visited. Nothing but cycle formation is possible. Okay, so like that you have to check it. Again, if you want it, you can able to check. So C to D. Okay, so if you go like this, cycle formation is possible. You can check it. Nothing but what exactly it says that if the vertex is met. Okay, if you visited that vertex edge, automatically it creates a cycle. That is the reason why I am telling that cycle checking is easy. Cycle checking is easy. Understood, everyone? I think you people got this. I think you people got this. Each and every time you have to check the vertices. Okay. Suppose if the node is not, if the vertex is not visited, that is what exactly I'm telling. If the vertex is new vertex, okay, if the vertex is new vertex is nothing but not visited, nothing but that is disconnected. Okay. Suppose think like that. This is a graph right now. This is what I'm talking about. Disconnected means how, sir? How, sir? Disconnected is nothing but see, initially, am I visited A? No. Am I visited B? No. Am I visited D? No. Am I visited C? All are new. All are new. All are new. Nobody visited. That is the reason why it is a disconnected. Yes or not? That is the reason why it is a disconnected. So if I visited means then it will be a connected one. See, I visited A. Yes or not? First I selected A. Yes or not? I visited. What is the best adjacent vertices? Best adjacent vertices. I checked everywhere. For A to B, it is taking 7. From A to D, it is taking 6. From A to C, it is taking 2. Best adjacent is A to C. That's what I selected. Nothing but what? Both the things I visited or not? Both the things I visited or not? Mark as visited. If I mark this one as a visited, if I mark this one as a visited, nothing but these are all old. These are all old. Okay. If old, that is nothing but visited. Now see here, everybody observe here. So A is already visited. Yes or not? Nothing but I marked here very clearly, already visited. C already visited. I marked here very clearly. Now see here. Now here from A, I will go to check many adjacents which are best one. See here, A to B, how much time it is taking? 7 units. Again, A to D, how much time, how much units it is taking? 6 units it is taking. Again, that is over. Again, check with the best one. What is that? C, nothing but C to A, C to B, C to D, C to F, C to E. All are there, all are there. But see the units, okay, which is the best one in this, which is the best one you will going to select. Okay, so that is from the C, best adjacent path, best adjacent vertex is what? That is F. Nothing but how much units it is taking? 5. But this one 6. But here if you go C to A, because already it is created, C to A already it is created, nothing but created, nothing but it is already visited, nothing but it creates a cycle. Okay, so that is what I wanted to say. That's the reason why you got this. That is the reason why you got this. If it is visited, nothing but already it will going to create a cycle. Please understand that. Okay, please understand that. Okay, fine. Now, step 4 is okay. Everybody okay with step 4? Like step 5. Step 5. We will see that step 5 now. I think every people are getting, all are getting what I'm saying. Okay, all are getting. So new means it is a disconnected one. Old, okay, old and new. Just understand old and new. So it indicates very clearly no cycle formation. No cycle formation. New is nothing but what? Not visited, not visited, not even one time also visited. Old is nothing but one time visited. New is nothing but one time not visited. One time also not visited. If both are, you are having the indexes like this, no cycle, you can able to connect it. Understood? You can able to connect it, no problem in that. You can able to connect it. That is what exactly I'm talking about here. Nothing else. Apart from that, nothing else. Yes or not? Now, okay. See here, everyone. So step 5. Everybody observe here. Step 5. Step 5. See here. A is done. A is done. Okay, na? So A to C. A to C. Again C to F. C to F. 2. Again 5. Again 6. So from B. Okay. So again this one. Again F to D. That is 3. So these things are over. Right? Everybody okay? Now see here. All the vertices we got it or not? See, check it. How many vertices are there? 1, 2, 3, 4, 5, 6. Nothing but A is done. Okay. Again C is done. Okay. Again F is done. Okay. Again D is done. Okay. Again, what is there here? B is done. Okay. So what is left? E. E is left. E is left. Okay. E is left is nothing but what? No need to check in this way. What is that? Hence, before what we are doing from each vertexes, we are checking, right? No need to do like that. Please understand. No need to do like that. These things nobody will tell. No need to do like that. So from the E vertices, please here from the V vertex, which is the best one, you check it. Which is the best one, you check it. 9. It is taking 9 units. It is taking 8 units. It is taking 4 units. 4 units are better or not? So this is the better. That's it. Over. Game over. So this is how you're going to create the MST, minimum spanning tree. That's it. Clear? Everybody clear? Everybody clear or not? So this is how you're going to create it. This is how you will going to create it. Fine. Finals here. Everyone observe here. So this algorithm, see here, Prim's algorithm actually, Prim's algorithm actually equivalent to Dijkstra's algorithm. Okay, Dijkstra's algorithm. Dijkstra's algorithm. I will discuss all those things. Don't worry. That is the reason why I said very clearly, Prim's algorithm is nothing but adjacent better. Which adjacent is better? Take that one. Which adjacent is better? Take that one. So whatever the algorithm, whatever the graph we have taken, same graph I will going to write once again. Please here, same graph I will going to write once again. A. Again from here, I will take B. Okay. Again from here, I will take D. Again here C. Okay, now here E. Again F here. Okay, everyone okay? I will connect all this. I will connect all this. I will connect all this from C, D, F. Again E. Now everybody observe here. So this is 7. Okay. This is 6. Here also you connect. That is 2. Again 6. Here also 6. Again 3, 5, 8. Again here 4. Again here 9. Okay. So here, this is a. Now please everybody, what I will going to do, please everybody observe here. This one actually we have done with the Prim's algorithm, right? We have done with the Prim's algorithm. Okay, using Prim's algorithm we have did this one. Now using same graph. Okay, same graph. Using same graph. Okay, use the same graph and do using Kruskal algorithm. Using Kruskal, I am talking about using Kruskal here. Using Kruskal. Using Kruskal. You check it. Using Kruskal. Same thing. Same thing. You check it first. Check the minimum in this. Everybody check the minimum. Okay. Here edge by edge. Kruskal is nothing but edge by edge. Please understand. Edge by edge. Prims is nothing but vertex by vertex. Okay. This is important. That's the reason why. If you know these two words, you will get it. Everything you will want to get it. So now edge by edge is nothing but which is the minimum edge in this? A to C. Take the minimum. A to C. A to C. Yes or not? A to C. Done. A to C is done. Which is the minimum again? Okay, see here. Which is the minimum again? 2 is done. Again F to D. F to D. F. Again D. Okay, F to D. F to D, correct? F to D. What is that? 3. Again, take the minimum. So 2 is 3 over. Again 4. E to B. E to B. Say, take that one. E to B. E to B. E to B. Okay, E to B. So that is 4. Done. Now you tell me, is it forest or not? Have it? This is connected? Tell me now. Is it connected now? No. That is the difference between Prim's algorithm and Kruskal algorithm. Basically, Kruskal algorithm will going to put a comment on Prim's algorithm saying that why you are doing all like that. Okay, why you are following this procedure. Always you are connecting, taking the best minimum, taking the best minimum. You can take the minimum, right? Directly edges. But this cannot say anything because the reason is finally you will going to get the proper answer. Yes or not? Finally you will going to get the proper answer. So that's why what it will say, okay, let me see. Okay, what it will do, it will going to complete now. Now see here everyone, after this 4 is over, again see here which is the minimum, 5 is the minimum, C2F, C2F connected. Yes or not? C2F connected 5. Clear? Again, which is the minimum? Which is the minimum? You check it. Which is the minimum? Okay. If I take C to D, please here. If I take C to D, cycle creates or not? Leave it. Don't worry. Okay. Again, if I take A to D, A to D, cycle creates or not? Leave it. Don't take it. Okay. Again, one more is there. Okay. B to C, B to C. See, cycle creating? No. Cycle creating? No. So this is the MST. Kruskal MST. So it says that very clearly. See here, it says that very clearly. Okay, so you can take minimums. Okay, you can take minimum edges and you can able to do it. But this method is totally different. This method is totally different. But one thing you will going to see the similar one. What is that? Cost. Cost will be similar. And your graph minimum spanning tree will be similar. Okay, so this one you have to observe in this. This one you have to observe very clearly. Clear? Okay, so both argues, see here everyone, both argues, both, okay, Prim's as well as Kruskal algorithm, Prim's as well as Kruskal algorithm, both the algorithms, okay, give same answer, same answer. Suppose if you take these values, okay, what are those values? 4, 6, 10, okay, 10. So let's write like this. So what is that? 4 plus 6 plus 5 plus, okay, now, so 4 plus 10, again 5 plus 3, 8. Correct? Correct or not? Okay. So now 10 plus 8, 18 you are getting. Same answer you will want to get in the Prims also. Same answer you will want to get in the Prims also. Same thing. 4, 6. Okay. One more is missing here. Let's see that one. What is missing here? Anything is missing? Guys, anything is missing? Tell me. 4, 6. Okay. So here. Weight is missing. 8 is missing. Plus 2. Plus 2. That is equal to 20. Okay. Now you see. Weight is missing. Here also same thing. Okay. Here you can able to see here. Very simple. 4 plus 6, 10. Okay. Again 2 plus 5 plus 3, 8. 8 plus 2, 10. Again 10 plus 10, 20. Answer gives same. Here also same. Here also same. Here. Answer gives same. Okay. But approach is different. Different approach. Again, suppose if the cost is same, okay, suppose think like that, everywhere 77777 like that is there, then multiple MSTs are possible. Multiple MSTs are possible. Okay, multiple MSTs are possible. Okay, but same cost you will going to get it. Same cost you will going to get it. Okay, this is all about Prim's algorithm. This is all about Kruskal algorithm. I given the difference on time complexity, everything I have given. Few more things are there. Tomorrow I will going to discuss. What is that approach? We will going to discuss tomorrow. There is a data structure, disjoint. Okay, set data structure. I will going to discuss tomorrow related to Prims as well, related to Kruskal as well. Okay, now. So these things you have to study. Okay, I think I given the best thing. You can follow this one. Okay.